welcome to class. We're going to talk about the two problems that you did about parametric equations. Second day of us looking at free responses, so hopefully this first one in particular started to be a little bit straightforward. You kind of see they like to ask the same things over and over in these problems. So if you can get kind of the basics down of position and speed and distance and so forth, you're in pretty good shape. So this is first problem here. You are given dx dt and dy dt. You're given the position when t equals 2. And then part A says, is the horizontal movement of the particle to the left or to the right when t equals 2? And you're explaining that. Well, horizontal movement, so we're talking about the x direction. So we need to look at dx dt. Dx dt is a positive number here. I don't know exactly what positive number that is because I don't have my calculator out. But that is certainly a positive number. And since dx dt is positive, we know the particle is moving in a positive direction in the x direction. We say it would be moving to the right. And then the other part of part A, they want to find the slope of the path. So dy dt over dx dt. You're given both of those. You just have to plug in t equals 2. And 3.055 appears to be what that rounds up to. Notice that it's important to show them that you know where dy dx is coming from. Say like, hey, look, I know that this is just dy dt over dx dt. You know, set that up on paper before you substitute the 2 in, just like we've done in other times. Part B wants to know the x-coordinate of the particle's position. So we know the position is 1 at the beginning here when t equals 2, which is the only time they give us here. It's the position x is 1. So then we need the displacement in the x direction. So we integrate dx dt from 2 to 4 here, not 0 to 4 because they just told us to start at 2. Our initial value was what happens when t equals 2. So if you integrate there from 2 to 4, again using the calculator, that integral comes out to like 0.253. But remember, that's displacement. You have to add to the 1 from the initial position to get the answer of 1.253. Speed of the particle, square root of dx dt squared plus dy dt squared. When t equals 4, just calculator will do all that for you. Acceleration vector, again, we already have x prime or dx dt. Take the derivative of that, plug in 4. Take the derivative of dy dt, plug in 4. Just make Math 8 do those things for you. You don't have to actually take those derivatives by hand anywhere. And it's good to show them, hey, I know that acceleration is the derivative of velocity, or it's the second derivative of position, is the way they've written it there, is x double prime of 4 and y double prime of 4. And then finally, distance traveled, aka arc length. Integrate from 2 to 4. They give you the bounds again. Your speed expression, square root of dx dt squared plus dy dt squared, math 9, and you'll get that number 0.651 out. Okay. So again, pretty straightforward. And you'll notice the average score for that one is again very close to 5. The other one, and this is the most recent problem. Yeah, this is from last year, I believe, right? Yeah. So the 2016 problem here. They threw a little twist in, and you'll notice from the scoring guide there that the average here is just slightly lower, and I think that's because they've done something a little bit weirder. Let's see, I move that down so maybe you can see that in graphs. I might come point to that graph in some spots. Yeah, that looks good. Okay, so as before, we've got a particle moving parametrically. We're given dx dt like we've been given that several times so far. But now we're given the graph of y, and notice that's not dy dt, that's the graph of y. That's telling you positions, and which says when t equals 0, the particle is at position 5, 1. We knew the 1 because here's the position in the y direction when t equals 0. It's actually at that value of 1. So when part A says what's the position of the particle when t equals 3, jump to the y coordinate. We just want y of 3, pulling that straight from this graph, -1/2. We know that's exactly at -1/2 because it says this is a line segment going from -1 to 0 there. So the y-coordinate is simply a number we're pulling from that graph. The x-coordinate, we do that like we've done the other ones. We take our initial position, which was given to us as 5, and then we find our displacement. Integrate dx dt with respect to t. Make the calculator do that for you. You're going to end up with 14.377 as the position in the x direction. So a little bit different there, having to use the graph of y to find that value. Same thing in part B when you want to know the slope of the tangent line. We know that's dy dt over dx dt. dy dt here is the slope of that graph of y when t equals 3. So we're looking again at this place, but not the value on the graph now, but rather the slope at that point. So the slope of that line segment, you can tell, is 1/2. So that's dy dt for you there. dx dt, we plug in 3 into that expression they give us. 9 plus sine of 27 apparently is that decimal there. I don't know why that just says 0.05. I don't know why that's not correct to 3 decimal places there. Like, there's no way that comes out to exactly 0.05. Be real careful about that. Actually, maybe something maybe you can tell me in class why that 3rd decimal place isn't there. Even if that 3rd decimal place is a 0, you should be writing it. Because if you stop writing decimals, that implies that everything's a 0 forever. And so I don't know why they did that. I feel like that should be 0.050 or something like that. Okay, so part C, find the speed of the particle. Hopefully you're real familiar with this formula now. Square root of dx dt squared plus dy dt squared. You're given dx dt. You found dy dt at that when t equals 3. That slope is 1/2. Put all that in. Let the calculator give you that number out of 9.969. And then finally, total distance traveled is a little bit more interesting here in part D than it has been in the past. Good idea to show them just generically at the very beginning there. Hey, I know to find total distance traveled, I'm going to integrate from 0 to 2 my speed expression. All right? And note that gives you a point just for writing that down. Now the twist here is that because y is piecewise, dy dt is different from 0 to 1 compared to from 1 to 2. dy dt from 0 to 1 is the slope of this line segment, is -2. dy dt between 1 and 2 is the slope here, which is 0. So they've split this up into 2 separate integrals. They've looked at the integral from 0 to 1 for this piece, plugging in -2 for dy dt. And then they've done a separate integral from 1 to 2 with this slope of 0. The dx dt part won't change. dx dt is the same for all values of t. But because y is piecewise, you have to consider those as 2 separate pieces along the way. So that you've split up the 2 integrals there, and you end up with an answer of 4.350, which they did put the 0 on that one because it rounded up from 4.349. So that's the idea of that one. My guess is the reason that the scoring was lower there is dealing with the graph of y instead of an expression for y or dy dt, and also handling the splitting up of the integrals there that you get in part D. So we can talk about this one, both of these actually, at the beginning of class tomorrow or next time I see you or in school or something like that. So we'll see you soon.